What's going on, guys? Today I have something a little bit different for you. Pergear sent me an infrared camera setup that plugs into your iPhone. So why do I need this? Well, I thought it would be pretty interesting to see the heat emissions from some of the printers that I have in for review. Plus, inside my job we recycle tons of batteries, which could be prone to thermal runaway while in dry storage. So using this type of camera could prevent potentially a fire. On the 3D printing side, of course, the heated bed, nozzle and airflow. But one thing to remember is that different metals react to heat differently. So we're going to be using this mainly as a guide. So let's get into the crux of this. The Xinfrared T2S Plus is a smartphone thermal imager that can capture heat images of objects that are not visible to the naked eye. With its built-in 8mm focusable micro lens, you can zoom in on your subject. The device has a high-precision temperature measurement capacity, measuring up to 450 degrees C, with an accuracy range of around about 2 degrees, making it ideal for industrial applications. The 256 by 192 pixel core allows for detailed imaging, while its powerful analysis capability can help identify problems on things like circuit boards. The device has been designed specifically for PCB detection, microcircuit detection, having HVAC detection, and finding heat loss, insulation conditions, electrical problems, and water damage. Plus, it has a battery-free design, and you don't have to worry about running out of power in the field. However, it is connected to your iPhone, of course, so you kind of do have that issue. Either way, it's a small and very compact device. It does also come with a pistol grip, which I didn't use for most of this video, but the camera lens also has a dust cover and it wraps up into a small egg-like protection pocket. I don't think you can own one of these cameras without going on a little adventure around the studio and outside to see what's hot and what's not. So firstly, the heat of my hand onto a PLA print, which leaves my handprint, then a heated fan on the floor that's heating the room, one of the 3D printers that's also in the room, and as you can see, the bed is red at 60 degrees, and the plastics on various parts of the printer are also emitting heat from the boards. Laptop chargers, before I found the option in the end to read the temperature by selecting the square to measure the temperatures. Before, of course, I found somebody having a cigarette outside, and well, we filmed that as well. Why not? As I said earlier, one of the primary uses for this camera is working on circuit boards, so this can be really helpful when working with my sponsor, PCBWay.com, your one-stop destination for top-quality circuit boards at unbeatable prices. Whether you're a hobbyist or professional, they have the perfect solution for your electronic needs. Their experienced team and latest manufacturing technology is there to ensure that your circuit boards meet the highest industry standards. At PCBWay.com, they offer a wide range of services including PCB fabrication, PCB assembly, PCB prototyping. You can choose again from a variety of materials, sizes and shapes to fit your specific requirement. Plus, their easy-to-use online ordering system makes it quick and convenient to place your order. Then you can use this camera to measure the heat. How cool is that? As we're on the topic of circuit boards, I have captured an image of an RGB controller board that's currently in an off state. You'll notice there that the red areas on the board where thermal reflection is apparent on some of the metal components. But once powered on, these areas will show signs of heat emitting from the chips, capacitors and resistors. Unlike a human touch, the thermal camera can detect temperature variances across the board, making it efficient in identifying current-consuming components. Any part of the section of the board that's drawing current will generate heat, which the thermal camera can pick up easily. The app enables you to mark specific areas of the board that you wish to monitor by drawing into those sections. You can select multiple boxes and the app will provide you with feedback on the temperature of the heated areas. These readings are highly accurate within a few degrees, and it eliminates the need for physical contact with the components. The thermal reaction from cold to hot water in my kitchen hot tap was interesting to see. It first emits a cool blue, then what almost looks like hot molten lava. This technology can be particularly useful in industrial or scientific applications where monitoring the behavior of hot water is crucial for safety or experimentation purposes. The Xtherm app for iPhone is actually pretty basic and did display in Chinese when I opened it for the first time. To correct this, if you click the world icon, it will give you the option for English. Additionally, there are settings for heat correction, humidity, reflection temperatures, distance and environmental heat and emissivity. Now that's a measure of how well the material radiates the heat. One other thing to mention, in the Q&A on the app, it does suggest that the camera is powered on and stabilised for between 5 to 10 minutes each time it's used. Adding to the atmospherics on the app will also aid to the correct thermal responses within the app. As a first-time user of a thermal camera, I'm unable to give a comprehensive comparison with other similar devices currently available on the market. Nonetheless, based on my test, the Xinfrared T2S Plus does seem to perform exceptionally well. In particular, the accuracy measurements of the temperatures on my 3D printing and also boiling hot water provides reliable readings in real time. Overall, I have been impressed with the capabilities of this thermal camera. I would certainly recommend it to anyone in need of precise temperature measurement in their day or working life. Finally, thank you to Pergear for letting me review this.
You are watching a master at work.